Alright, so what we want to do today is figure out how we can graph a system of linear inequalities. Alright, so the first thing we want to do is look at a couple of inequalities. It's a system, right, because it's two or more inequalities with the same two variables. So we want to tell whether each ordered pair is the solution of the system of linear inequalities. To do that, we have to know that x and y here, or in this case 3 and 5, will be substituted into the inequalities and make a true statement. So I'm going to take inequality 1 and replace y with 5 less than 2 and then replace x with 3. So if I simplify, that's 5 is less than 6. Well, that's true. 5 is less than 6. Now we'll take the second inequality statement. Y is still 5. X is still going to be 3, so 5 is greater than or equal to 3 plus 1. Well, 3 plus 1 is 4. 5 is greater than or equal to 4. That is also true. Since both are true, this means 3, 5 is a solution. Okay, let's try part B here. Again, with the x is negative 2, y is 0, so we go back to inequality 1. Y is 0 less than 2 times negative 2. So 0 is less than negative 4. That is false. So it actually doesn't matter if the second one is true or not, because the first one was false, so negative 2, 0 is not a solution. Alright, let's take a look at some more information. Graphing a system of linear inequalities. When you graph the system, you're going to graph each inequality on the same plane. Okay, so here's our two inequalities. Y is less than x plus 2, y is greater than or equal to 2x minus 1, and you graph each one on the same grid. Then you're going to find the intersection of the two things. So here, y is less than, we went down, right, from that line. Here y was greater than, so we went up. So the section where the two intersect is here between the dashed line and the solid line, and from the intersection point of the two lines. Okay. So graph this system of linear inequalities. Y is less than or equal to 3. So we go to 3 on the y-axis, and since if this was an equal sign, y equals 3 would be a straight line through here, but since it's an inequality sign, it's also going to be a straight line because we have that less than or equal to. Okay, so it's a solid line, and less than, where the y is less than 3, as we go down from that line. Okay, so that whole area, that's the graph, right, of y is less than or equal to 3. I'm going to change colors, okay, and y is greater than x plus 2. So I go to 2 on the y-axis and plot my point, and my slope is going to be 1, so I'm going to go up 1 to the right 1, up 1 to the right 1, and so on. Okay, and because it's strictly greater than, it's a dashed line through those points. Okay. All right, and y is greater. Where is the y is greater? As we come up from here. Okay, so our shaded area, right? Let me pick a different color. We'll go with the yellow. Okay, our shaded area, or our solution, is this section right here where the red and the purple overlapped. Okay, so this bit of triangular space here. All of that is the solution. Okay, so graph the system of linear inequalities. And we have 2x plus y is less than negative 1 and 2x plus y is greater than 3. Well, in order to graph this, I'm going to either substitute some points or solve for y. I'm going to choose to solve for y because if I solve for y, then I can put this inequality in my calculator, and if I don't, I'm pretty sure there's not any way I can put the inequality in my calculator. Okay, so both of these, the 2x here, needs to go to the other side. Right? So I'm going to say minus 2x, and over here we'll also have minus 2x. Okay, so I'm just going to rewrite those. Y would be less than negative 1 minus 2x, and y would be greater than 3 minus 2x. Okay, so I want to show you how to use your calculator for this one. So here we don't want an equals, right? So we're going to use our delete button and go back, and our first equation was less than, so we're going to pick the less than symbol, which is number 2, and then we're going to type the rest of our equation, which was negative 1 minus 2x. So negative 1 minus 2x. Okay, and go ahead and hit enter. All right, and so that's what it's going to look like. So we're going to hit tab, and we're going to use our delete to back it up, and then our second symbol was the greater than symbol. So we want to select number 4, and then we type the rest of our equation, which was 3 minus 2x. So 3 minus 2x. We hit enter, and you can see we have two graphs here, right? Well, we're shading on either side of them. So this line is parallel to this line. They're never going to intersect. This shading doesn't overlap with this shading. So what that means for us is there is no solution. Okay? So let's go ahead. We can see that one of our lines is crossing the x-axis, the y-axis at negative 1, and our other line is crossing at positive 1, 2, 3. Okay, so going back here, y is negative 1 minus 2x. It was crossing at negative 1, and then it was going down to over 1. Okay, down to over 1, down, well, that's as far as we can go. So we can go up to the left 1, up to, and we can just get points off our calculator for that. And it was a dashed line. And we shaded over this direction. And then our second line was going through a positive 3, and it was parallel, so down to over 1. Okay, and it was also going to be a dashed line. And it was shading in this direction. Okay, so we would say this is no solution. They have nothing in common at all. Write a system of linear inequalities represented by the graph. Okay, so if it's a system, we know we have to use the same variables. Since it's on the graph, we're going to use x and y. So I'm going to look at this solid line here, and it is going through the y-axis at negative 2. So that means that y is going to always be negative 2 since it's solid, right? We know that we have the line underneath, and because we're going up on our shading, that's where the shading is, that would be greater than negative 2. Okay. Then the second line, it's going through the y-axis at 0, and it has a slope of 1, right? Because up 1 to the right 1, up 1 to the right 1. Okay. So y, and I'm going to leave my symbol blank, right? And we begin at 0, and we're adding 1 over 1x. It's a dashed line, so it won't have the line underneath. We're shading below the line, so we're going down, so the numbers are less than. Okay, and then most likely we would clean this up. simplify it because we don't really need the 0 or the 1 over 1, so we would just simply say y is less than x. And that's our system. Write a system of linear inequalities represented by this graph. Okay, so I've got this line here. It's a vertical line, so I know those are x equals lines. And what is x equals? Equal? It's equal to 3 because we're going through the x-axis at 3. So x is related to 3. Now we have to figure out the inequality symbol. Okay, so we're shading in this direction, so that's where the numbers are less. And because my line is solid, I know it is also equal to. So x is less than or equal to 3. All right, then this is a diagonal line. It's got a slant to it. I know it's going to be a y line. We go to the y-axis, and it is going through at positive 1. So we began at 1, and we're moving up and to the right. So it's a positive move up, and we're moving up 1, 2, and then over 1, 2, 3. So we're going 2 over 3 x. Okay, it's a dashed line, and we're shading up. So that's going to be up is greater than, and it's dashed, so we do not put the line underneath. And there's how we write our system of linear inequalities for this particular graph. You have at most 8 hours to spend at the mall and at the beach. Okay, you want to spend at least 2 hours at the mall and more than 4 hours at the beach. Write and graph a system that represents the situation. All right, so the first is, okay, we're going to have to graph it, so I'm going to use x and y. So let's let x be the time at the mall. And y be the time at the beach. I don't see anything in there that would make one independent or dependent. They're just two separate situations. So you could have certainly gone the other way and said x was the time at the beach and y was the time at the mall. But once you decide, we're going to stick with that. So the time I'm spending is going to be combined, so x plus y, and at most 8 hours means it's going to be greater than, less than or equal to 8. Because at most, I can't go over 8. All right, then you want to spend at least 2 hours at the mall. Okay, the mall time was x, so my x time needs to be greater than or equal to 2. And then my beach time is more than 4 hours, so I want y to be greater than 4. All right. Now this is 3 inequalities, but it's still a system because in 2 variables, so we would want to graph these 3 lines to be able to graph the system. Okay, the x is greater than or equal to 2. That's pretty easy. We just draw a vertical line at 2. And it's solid, and the numbers are greater to the right, so this is our shaded area to the right. I'm going to change up colors. At y is greater than 4, that's a horizontal line at 4, and it will be dashed because it's strictly greater than 4, so we're doing our dashed line, and we're shading up because they're greater than. All right, and then finally, x plus y is less than or equal to 8. We want to change that, so we'll move the x to the other side, and we'll have y is less than or equal to 8 minus x. Okay, so we'll begin at 8, which is actually off the screen here, so 7, 8. And then we're moving down 1 over 1, down 1 over 1, down 1 over 1. And it's a little hard in here now because we've done all that shading. Okay, so down 1 to the right 1. And it will be a solid line. and the shading will be below the line. So this little triangle here is where all three lines intersect and the shading overlaps. Okay, so I'm going to pull that out because it's a little hard to see, but this point is at 2, 6. Then we go down to 2, 4, and we're coming out to 4, 4. Okay, and I need to go back. This line should actually be dashed, right? And the other lines are solid. Okay, so how much time can you spend at each location? Well, X represents the time at the mall. So what are our possible X values? Well, 2 is a possible X value. Okay. We have it here at 2, 6, 2, 4, and several points in between. So we know that at the mall we can do as little as 2 hours, and then we can go up to how many hours? Well, our largest X value is 4, so we just need to check. It's a little confusing because it's solid on the diagonal line, but it's dashed here, so we need to check, will 4 as an X value work in our equations? Well, we know it will on this solid line, okay, and we know that 4 is greater than or equal to 2, so it works in that equation. And then there isn't an X in that equation, so yes, we can go up to 4 hours at the mall. Then we look at the beach. Okay, so at the beach, we know that we have to be greater than 4. Okay, so looking here, this dashed line being at 4, because 4 is not greater than 4, it's got to be more than 4. So more than 4 hours. And we can go up to 6 hours. Okay? Because our top Y value here is 6. Okay? So if we check that out, now we can't go 4 hours at the mall and 6 hours at the beach, right? If we go 6 hours at the beach, we're only going to be able to do 2 hours at the mall. So it's not, we're not matching points this way. We're just saying at the mall we can spend 2 to 4 hours, and then we have to spend more than 4 hours at the beach, but we can only be up there up to 6 hours. So at 6 hours, 1 minute, you know, or 1 second even, we've gone over our 6 hours. Okay. Okay, so name an ordered pair that is a solution of the system of linear inequalities. So if it's a solution, it's somewhere in this shaded area, or it's on a solid graphed line. So I'm going to give you several examples of a solution. So right here, this would be a solution at -1, +2. This would also be a solution at +1, +1. We would also have a solution here at -2, -2. Okay. And there's an infinite number of solutions. Those are just some that are easy to see. Okay, name an ordered pair that is not a solution. Okay, again, there's an infinite number of those. Not a solution would be anywhere that's not on one of these solid lines or not in the shaded area. So if we came out here or over here, right, down here, those would all be examples of not a solution. So that would be the point 1, 2, 3, 1, 2, 3, 3, 3. 1, 2, 3, 1, 2, 3, -3, 2. And and then positive 1, negative 4. Now, one thing to keep in mind is if it's a dashed line, you have a dashed line, which we don't here, but this is to help you with your work later. If you have a dashed line and the point is on the dashed line, not a solution. All right. You'll now need to finish puzzle time for 5.7, and then you also have a worksheet that will give you practice on solving and graphing inequalities.